Example 1. Suppose that a market research firm is hired to estimate the percent of adults living in a large city who have smartphones. They found 84% own smartphones. You decide to see if this proportion is the same for students at your school and survey 100 randomly selected students. What value of the sample proportion p hat would be consistent with the claim that 84% own smartphones? To investigate this, you simulated 500 samples for n equals 100 from a population for p equals 0.84 using StatCrunch. This is shown below in the dot plot of the sample proportions p hat of students who own smartphones. So here is our simulation. So part A, what does this one dot at 0.75 represent? So I want to make sure that you understand what we just did when we simulated this. So this represents one of the 500 simulations. So it would be like maybe you had 500 people go out and survey students. In practice, we do not do this. We get one attempt. So that one dot at 0.75 represents one of the simulations. So one of the simulations resulted in 75 over 100 who had a smartphone, or 0.75. So how would you describe the shape, center, and spread of this distribution? We should be pretty good at this by now. Very close to normally distributed, symmetric, center at about 0.84. Samples range from about 0.74 to 0.94. It's sometimes hard to tell when you've got a lot of values. I think we can see what's going on here, though. Part C. Would it be surprising to get a sample proportion of 0.95 or higher from a sample size of n equal 100 when p equals 0.84? And explain. Again, if you haven't been doing this, go ahead and pause the video here and think about that before we go over the answer. Yes, it would be, because none of the 500 samples in the simulation resulted in a sample proportion of 0.95 or higher. Everything ranged between 0.74 and 0.94. Suppose that 95 of the 100 students surveyed said that they had a smartphone. What would you conclude about the firm's findings? Well, it would be very unusual, sometimes we use the word surprising, to get a sample proportion of 0.95, or anything higher than that, of course, in a sample where n equals 100 and p equals 0.84. So we would conclude that there is a higher proportion who have smartphones at this particular school. Example 2. In a recent study reported October 29, 2012 on the Flurry blog, the mean age of the tablet users is 34 years. Suppose the standard deviation is 10 years and that the distribution is modeled well by a normal curve, in parentheses 34, 10. A student wanted to know if it was true in her community and randomly surveyed 50 people in her town. What value of the sample mean x bar would be consistent with the population being in 34, 10? To investigate this, you simulated 500 samples for n equals 50 from a population that is normally distributed with a mean of 34 sigma of 10. This is shown on the next slide in the dot plot of the sample mean x bar years of people who own a tablet. So what does that one dot at 30.1 represent? This is very similar to example 1. One of the 500 simulations resulted in a sample mean x bar of 30.1 years old. So how would you describe the shape, center, and spread of this distribution? It's very close to normally distributed, symmetric, center at about 34. The samples range from about 30.1 to about 37.2, and there don't appear to be any outliers. Part C. Would it be surprising to get a sample mean of 37 or higher in a sample of n equals 50 when the population mean is 34? And explain. So I've shaded that part for you. So it would be. There are only 7 of the 500 samples, so 1.4%, in the simulation resulted in a sample mean of 37 or higher. Our threshold, and we'll talk more about this threshold in a subsequent lesson, is generally set at about 0.05. So anything less than 5% we would consider unusual or surprising. Suppose that the average age of the 50 people in our sample was x bar equals 37. What would you conclude about the population mean, mu, who own a tablet in your community? So we conclude that the mean age in our community was significantly higher than the mean age reported in the Flurry blog.